Hi everyone, welcome to my talk. And my name is Devansh Batham, and as you can see, the title of the talk is Sacrificial Lambs of the Internet. Now, the title looks a bit scary, but by the end of this talk, we'll come to know why exactly I chose this title. This is a bit about me. So, my name is Devansh Batham, and currently I lead the triage team at HackerOne. I am a part-time security researcher, primarily focusing on DNS and supply chain security. I have reported more than 250 DNS security vulnerabilities to almost all of the Fortune 100 companies. I am interested in performing internet-wide scan, be it related to DNS, port scanning, or doing internet-wide, internet-scale DNS fingerprinting. And my handle on X is 0xasmodeus, so you might have read some of my threads about DNS security on there. I have wrote more than 20 plus security related tools, including ParamSpider, FabFreak, OpenRedirects, CertEagle, and a dozen more. Other than that, I have helped fix organizations 500 plus vulnerabilities over the span of my 6-year career. All right, so before getting into the actual content, let's first do a little primer on DNS. And I'm pretty sure all of us know what DNS actually is. So at very core, DNS is like an address book of the internet. And what it basically does is it converts a domain name to its respective IP address. So you enter a domain name in your web browser. Computers don't understand domain names, so they need IP addresses. This is where DNS comes into the picture, and it converts your domain name to the IP address, and eventually you get the IP address and you navigate to this website, you are able to load the content of it. Now, what if you are trying to navigate to google.com, but it points to a phishing website? There will not be a way for you to tell that because the context of the web page will be google.com. So the origin will be google.com. It will be pointing to a different A record or a C name, right? So DNS hijacking is somewhat very difficult to identify for an end user that if the domain is actually vulnerable. So let's say I take over an A record of DNS.com and I serve my content there. Then for the end user, there will not be a way for them to tell that it actually is a phishing website because I can set up my certifications and everything. Now, DNS hijacking, historically we have seen a dozen variants of it. So we have seen subdomain takeovers where the attackers hijack either A record or C name record. We have seen name server hijacking where the attacker is hijacking name server of the domain. And we have seen some secondary context DNS hijacking as well, where you have referenced script SRC. It points to a third-party domain, and that domain is vulnerable to hijacking. So if you are able to hijack that, you can basically run JavaScript under the context of the actual vulnerable application. But this talk is not going to be about any of those cases. This is about something really new that I was researching about earlier this year, and I found that particular case to be very stealthy and scary because of its sheer scale. So let's just do a quick primer on how DNS resolution works. So let's assume that you are trying to navigate to google.com. First, the web browser checks the local cache of the device. And if the IP address for that domain name is present in the local cache, it fetches the IP and you get navigated to that website. But what if you're trying to navigate to that website for the first time? Then the local cache will be empty for that particular DNS entry. So now your operating system or your machine will ask the DNS resolver for the IP address of that domain. It could be, resolver can be your internet service provider's DNS resolver, or you can use Google's DNS resolver, that is 8.8.8.8. After that, the DNS resolver sends the query to TLD root name server. We have 13 TLD root name servers available. TLD root name server does not know the IP address of the domain, but it points you to the actual domain's name server. And from there, the name server gives you the IP address. So here you can see at the bottom of the slide, the flow. So let's say you're trying to navigate to example.com. First, the DNS resolver will ask the root name servers. The root name servers will then direct your query to the TLD.com TLD name server, and then it will redirect you to the name server of the actual domain that you're trying to visit, and then that name server will return the actual IP address. Now, there are some key players in the whole DNS ecosystem. I'm just going to be focusing on 4 of them. And first comes the registry. So let's say you are trying to register example.com as your domain. Here, .com is a TLD. All TLDs are managed by certain registries. So in this case, .com and .net TLDs are managed by VeriSign. So all of the .com TLDs, VeriSign has absolute control over all of the .com domains. Registrar is the one that sells you the domain names. So let's say you are trying to buy a domain, you will go to a registrar like Namecheap or GoDaddy. The registrar will contact the registry, and then you'll get the domain name. Registrant is the one who is buying the domain, so which is you. Name servers are the DNS records that hold other DNS records. So if you will run a simple dig query, let's say dig google.com plus ns, you will get the NS records for google.com, and those NS records will be responsible for holding the IP address for google.com. So if someone is able to hijack name server of any of the record, they can hijack the entire traffic flow of that particular domain. They can create arbitrary subdomains of that domain, and they can also create mail records for that. So they can create Google organization and bypass the entire DNS security checks because they control the DNS. So here is an unusual case of a DNS hijacking. I was doing bug hunting on one of the targets, and while scanning for DNS misconfigurations of their DNS dataset, I observed that one of their domain was returning a very interesting error code, which was serve fail. So I sent a simple dig query, dig followed by the domain name, and it returned the serve fail. So for you, for someone who is aware of what serve fail is basically an error in the DNS resolution process, which basically means that let's say you have example.com and you ran a dig query against it. Now the DNS resolution failed for some reason. As a result, you got serve fail error. Now the problem here is serve fail is very interesting because the DNS resolution failed at the name server level. So the entire DNS resolution was complete from your local cache to ISP, to TLD, to root, and finally to your domain. But your domain's name server, that's where the error is. That's why it is serve fail. Now, when I tried inspecting that particular domain, and you can inspect the DNS resolution using appending plus trace command in your dig command. So it will look like dig followed by the domain name and then plus trace. And when you will hit enter, it will show you the entire DNS resolution path. So in this case, what I observed was, here you could see that my domain name was redacted xyz.com. It was returning serve fail. And when I ran the dig plus trace command, it returned these errors. So that particular domain had 2 name servers attached to it, but both of these name servers were returning an X domain. And when I verified it further, those domains were available for purchase on GoDaddy. So anyone could register these domains and eventually hijack redacted xyz.com because name servers are the one that hold the DNS records for redacted xyz.com. Now, the problem here is, if you will see this pattern of the name server, it started with this string drop this host, followed by a random UUID, and then a random string, and then a .biz TLD. Now, this doesn't look like that someone will manually assign this name server. Like, it just makes no sense. The UUID is random, the string is random, and then this drop this host prefix on this domain. But at that time, I did not pay much attention to it, and it was, I think, in 2023. But I reported this issue anyway because I was able to hijack that particular domain, which was in the scope of a bug bounty program. And I was able to hijack this particular name server. And after that, I took control of the domain name. I reported it, and they awarded me a bounty of 3,000 euros. But this is not what interesting was. But the interesting was this pattern. So I want you to look closely at this pattern and just memorize it real quick. Okay. So now, I do a lot of internet-wide scanning, and I requested ICANN, which is an organization that manages all the DNS-related stuff. I requested scan for TLD data, and I specifically requested for zone files of all possible TLDs that they were available. So the zone file is basically a file that contains all possible domain names that were ever registered. So if I request ICANN for the zone file of .com TLD, it will provide me a zone file which will contain a mapping of all possible .com domain names and their attached name servers. And I got this for 500 plus TLDs. Major TLDs were .com, .net, .io, .org, and other TLDs like country TLDs, government TLDs as well. Now, after that, I used LLMs to detect patterns in surface responses. So when you are dealing with a large data set, let's say 300 or 400 billion domain names, you cannot, million domain names, you cannot really use tools like Dig because they are very slow. So I wrote some tooling in Rust, and I sent a single DNS query to each of these domain names, and I checked what error code they were returning. And I specifically looked for domain names that were returning serve-fail error code, and they had some name servers as well, but their name servers should return NX domain. So this case is very similar to this one. So I was looking for these kind of domain names where the domain name itself will return serve-fail, but their name servers will be giving me NX domain. Now, NX domain is not really a definite indicative that the domain will be available for purchase, but it gives us a starting point. From there, we can see what kind of pattern emerge. Okay, so I used LLMs to basically convert the natural language to the command, and eventually I got the responses. So my natural language query was, give me all the domains with serve-fail status code and NS returning NX domain. And I got thousands of results. And since I was using LLMs, it was possible for me to detect patterns. And one specific pattern really stood out. Now, look at this particular pattern. Here, you have domains, which I have redacted. They were returning serve-fail. They had some name servers attached to them, and the name servers were returning NX domain. Now, if you will look closely, the pattern of these name servers, it is very similar to that what I have shown earlier. So this was something I found in 2023, and this research I was doing in this year earlier in February. So this pattern reminded me of that particular finding, and now I was sure that this is not really a manual error. And these domains were owned by different companies. I was able to find at least 25,000 domains that were using this particular pattern belonging to 600 or 700 different companies. So it was not really an isolated incident. There has to be something systemic or mechanic flaw which was there. So I started looking deeper into it. I started with a simple Google search for this particular string, drop this host, followed by a UID, but nothing really showed up. I started reading documentations of Registrar, how they were doing it, but nothing really stood out from there as well. So I started doing DNS trace for these domains just to confirm that these particular domains indeed return NX domain and they were available for purchase, and that was the case. So I could have taken over these 25,000 domain names, but I was more interested in knowing what exactly is the root cause here. Because you can see the pattern was like this. Drop this host followed by a random UUID, then a random string, and all of these name servers were available for purchase. So my questions were who was assigning these name servers to these domain names and why exactly? Okay, so this discovery pointed to a systemic issue. So it was not really a human error because it's not like that 25,000 domain names will have this error. I mean, it could be possible if there were a dozen domain names or maybe a few hundred, but human error cannot exist in 25,000 domain names. Now, I started, since I could not find anything in the documentation provided by the registries or registrars, I started reading the absolute, from the absolute starting of DNS, since the DNS was came into inception. And I started reading DNS RFCs, and after reading more than 2 dozen RFCs, I got to know about the answer, and it was in the RFC 5731. Now, RFC 5731 had this particular paragraph, which will not make sense right now, but it will make in a bit. So I just want you to read it real quick. So a domain should not be deleted if subordinate objects are associated with the domain object, for example, and this particular example. We'll get to it later because right now it might not make sense. Okay, so there is something called EPP, and this particular RFC, it is related to EPP. EPP is Extensible Provisioning Protocol. So as I talked earlier, there are registries and registrar. Registry is someone who manages the entire TLD. Registrar is someone who manages that domain. registrars and registries need to communicate with each other. And for that communication, they use something called EPP, which is Extensible Provisioning Protocol. It is an XML-based protocol. And if a registrar needs to delete a domain, if it needs to update a domain or add new domain, it will use the EPP to issue EPP commands to the registry, and the registry will either accept or reject those commands, and it will either issue a success code or an error code. Here, registrar sends an EPP delete command for a particular domain name if the domain needs to be deleted. So let's say you purchase a domain name, and now you do not want to renew it. So you just left there for deletion. The registrar will send an EPP delete command to the registry that the user has not renewed their domain and it needs to be deleted. And once the domain is deleted, it goes to the pool of available domain addresses. This is the standard flow. Now, the problem is, let's say we have a domain name called example.com, and it has two name servers, ns.example.com and ns2.example.com. So example.com's name servers are subdomains of example.com itself, right? So it's a cyclical dependency. Now, if the registrar will try to delete example.com, the EPP will return the error code 2305 with the error message dependent object exists. So example.com cannot be deleted unless and until we take care of these name servers. So first, these name servers either need to be deleted or renamed. Now, I'll give you one more example. So let's say you have alpha.com. Alpha.com has one name server, ns1.alpha.com. Then you have beta.com, which is owned by a different entity, but beta.com also uses ns1.alpha.com, right? Now, registrar of alpha.com cannot delete it because ns1.alpha.com is present as a name server in beta.com. So deleting alpha.com will break beta.com and will make it susceptible to DNS hijacking. So this is why, to prevent DNS hijacking, error 2305 of EPP exists. So if I have a domain and someone else is using a subdomain of my domain as their name servers, I cannot delete my domain unless and until that person either renames it or deletes it. Okay, so registrars need to delete domains. So they eventually figured out a trick to do it. Let's say I have a domain, alpha.com, someone else has beta.com. Beta.com uses my domain as their name servers. So what registrar will do is they will rename their name server to a random string, and then they'll be able to delete my domain name. So here, the random string that they were renaming it, it was absolutely random. It was same like the pattern that I described earlier. Drop this host followed by a UUID, then a random string, and then .bistld. And the registrars did not check if the renaming convention that they are following, what if that particular domain itself is available for purchase? That will make beta.com susceptible to DNS hijacking. And this is where the actual issue was. I'll give you one example here, which will make things a bit more clear. Okay. So let's say there are two domain names, alpha.com and beta.com. Both of them use same set of name servers, ns1.alpha.com and ns2.alpha.com. Now, alpha.com forgot to renew, so they need to be deleted. But EPP has restrictions, so that alpha.com cannot be deleted because this exists as a name server of beta.com, right? So registrars will rename the name servers of beta.com to be able to delete this particular domain. Now, after, to be able to delete that, the registrar renamed it and changed it to ns1.some random string.biz and ns2.some random string.biz. Now, why .bistld? Because EPP does not allow you to rename it to a domain name which is available for purchase. But EPP's restrictions only allow on the same TLD. So VeriSign cannot control .bistld because it is controlled by another TLD. So here, the registrar cannot add a random string and .com domain. So registrars started using a trick where they started using a random string followed by .biz, which is an entirely different TLD. So they were able to overcome the EPP restrictions. Now, after the rename, beta.com has two new name servers, but beta.com played no part in it. Beta.com was completely unaware of this change. It was done from the registrar's end because the registrar wanted to delete alpha.com. So here you can see after the DNS propagation happened. These two, obviously random string .biz was available for purchase. So the attacker took control of these two name servers and they were able to take control of beta.com. Now, this is just one example. I was able to find at least 12 registrars that were following similar practices. They were basically renaming it to a domain which doesn't even exist. So as a result, the attacker was able to hijack these name servers, and eventually it will hijack all of these domain names that have these name servers associated with them. Now, drop this host followed by uuid.biz. It was one pattern used by one particular registrar to be used as a disposable name server, but there were thousands of domains, and I was able to identify more than a dozen name servers that were using different pattern of this name server, and this is why we call these name servers as sacrificial name server, because the registrar is renaming it to these name servers just for the sake of deleting some other domain. Now, this is a real-life case, what happened with TechTalk.com. This happened in early 2016, and I was not able to find a documented case around it, but I found it pretty interesting. So one day I was looking at the DNS history of TechTalk.com. Now, if you will see that on July 25th, 2016, it had DNS1.registrarservers.com, DNS2, DNS3, right? And on that particular day, those domains were deleted and 3 name servers were added. And those name servers, if you will look the pattern, registrar server followed by a random string name, then a .biz TLD, right? Now, registrarservers.com is a domain owned by Namecheap. So if you buy a domain at Namecheap, the default name servers that they will assign you, they will be following this particular pattern. But on July 5th, these name servers were removed and 3 new name servers were added with a very weird pattern and a .biz TLD, and those name servers were available for purchase. So anyone could have registered these name servers and hijacked TechTalk.com. But this particular issue was not isolated with TechTalk.com, because with Namecheap at that time, 1.6 million domains were registered. So anyone could have hijacked 1.6 million domain names, because all of those domain names were replaced with this particular string. Now, why that happened? Let's look at this. So in 2016, Namecheap employee accidentally tried to delete registrarservers.com domain, right? And for deleting, the registrar will send a EPP delete command to the registry. And after that, the registry will check if that domain has any subdomains that are added as a name server of other domains. And if that is the case, it will return an error and the deletion will not go through, right? So that error was received by Enom. E1 was a backend provider of Namecheap. And after that, Enom had a script. So as I mentioned previously, that registrars were using this practice. So whenever that error comes, just rename the name server and the deletion will be possible. So Enom was completely automating this process. So their employee accidentally sent a deletion request for registrarservers.com, which was their primary name server. And after that, EPP returned an error because its subdomains were attached as name servers of other domains. And after that, Enom ran a script, and that script will renamed all possible instances of registrarservers.com from all of these domains name server to these particular domain names, which were available for purchase. So after that, 1.6 million domains that were with Namecheap, all of them were vulnerable to DNS hijacking. Anyone could have hijacked any of the domains that was ever registered with DNS.com, Namecheap.com on that particular day. And to this day, this happened in 2016. To this day, 49 domains are still vulnerable, and those domains point to these particular name servers. Now, this happened because of the EPP restrictions and the way EPP wants registrar to rename name servers, and registrars are following very weird practices while renaming. They are just choosing name servers that can be easily available for purchase, and attackers just claim them. Now, after them, I have reported it to some of these registrars, and some of them have actually fixed it. But there are certain registrars that are still vulnerable. So here is how you can find these issues. Just request ICANN or any other registry for the TLD zone file. get that zone file and scan all of these domains and see and if any of these domains are returning serve fail error. Once you get them, fetch the name server for that domain. And once you get the name servers, just check if these name servers are available for purchase. If they are, then look for patterns and you might be able to find some other registrars. So this was the TikTok example that I mentioned. Before it was this particular name server. After renaming, it got changed to this. This change was applied to 1.6 million domain names, rendering them susceptible to a DNS hijacking. Now, this drop this host UUID random string.biz was just one pattern. There are more than 20 such patterns that registrars use. It could be random string.pwtld, random string /UUID, POD, PW. Then we have date patterns. So one example really stood out for me. What registrars really do nowadays is that they will rename, but they will not rename it to a random string. They will rename it to a domain that they control. And one particular registrar was renaming the name servers of domain while the deletion process to a pattern like date dot the domain name that they control, so that it is a subdomain of a domain that they control, so the other users cannot claim it. But everything was running fine, and I was monitoring these zone files from 2015 until after 2023. That dot after date and their domain name got removed. So it was one single domain where it was date, their domain name, .com. And since it is a one single domain name and no longer a domain, no longer a subdomain of their control domain name, I was able to hijack 18,000 domain names because the registrar was vulnerable, and that issue still exists. That's why I have not included that example in these slides, because it would have made it very obvious, and registrar does not want to fix it. They think it is working as intended, but I've sent multiple emails to them saying that removing by just one dot between the date and their domain name, it rendered entire renaming flow vulnerable to DNS hijacking. But the vulnerability still exists, and there are more than a dozen registrars that are still vulnerable to this particular vulnerability. And in total, when I did this research, 500,000 domains were vulnerable. Right now, the number has reduced, but still it is close to 200,000 domains, which is still a very large number. So all of them are available for purchase. Anyone can hijack some of these high-profile domains. Many of them are owned by Fortune 500 companies. Some of them were owned by companies that run bug bounty programs. So I was able to get a hold of them and report these issues. But yeah, this issue still exists on a very large scale, and the exploitation is very much possible. I did some pattern analysis, and I was able to discover that some hackers from Indonesia are running betting and casino sites on these hijacked domain names. So if they discover that one of the domain name is vulnerable to this particular DNS hijacking, and that domain name had good SEO prior to hijacking, then they will just hijack that domain and they will run their casino and betting sites. Now, for registrars, this is a vulnerability that the end user cannot fix because it is done by registrar. Your name server, your particular domain name will be vulnerable to hijacking and someone else will take it, but you had no role in it. You did not do anything wrong from your end. It was the entire doing by registrars and the conventions that they were following while registering, renaming domain names. So for registrars, what they can do is they should avoid renaming the name servers to external and unregistered domain names, and they can rename it to a domain name that they control. For registrants, that is us, we can monitor the name server history for our domain names. We can see if our own domain names return any of the error codes like serve fail or annex domain, and then we can act on it. So if you have a domain, just run a cron job and just do a simple dig command on it. It will return the error code. And once you get some error code, just review them if they are legitimate findings or not. And I think that is the only way, because this is an issue that we cannot fix from our side. It should be fixed from registrars, but registrars are very hesitant in fixing it. Now, the problem is DNS and EPP are tightly coupled. And before this research, I was unaware of EPP or even if it exists. But once I got into it, the flaws in EPP are so much because it's a very, I would say, it was adopted in early 2000s. And since then, there has not been any update in the protocol itself. So this is why it's a highly vulnerable system. DNS itself is very fragile. It has many moving parts. So you might see news like crypto protocol or blockchain protocol got hacked because their front end was hacked. So the smart contract itself was very solid, secure, but their front end got hacked. And by front end, I mean not JavaScript, but the domain name itself. So somehow the attacker was able to bribe the registrar employee, and the registrar employee gave access of that particular domain name to the hacker. And the users have no way to actually determine if the front end is hacked. So this is something that is very tricky. So I'm not even sure how to fix this vulnerability because it's a flaw in DNS itself. Now, registrar automation, automation that they use for renaming the domain names, that also needs safeguard. So that TikTok example, it happened because the registrar was using an automation script for renaming domain names. So there was no fallback method. It just got renamed. And host object renaming is a risky cleanup tactic. So registrars should start following something different. Some registrars have started using sinkhole domains while the renaming processes. But with one particular registrar, I discovered that the sinkhole domain that they were using, that domain itself was vulnerable for hijacking. So that really also opens a door for DNS hijacking. So that was all from my talk. My blog is available at devanshbatham.hashnode.com, and I have blogged about this particular issue. I have given some specific example of registrars there, so you can check it out. My tools and open source work is available at github.com/Devansh Batham. On Twitter, I'm active as 0xasmodeus. So if you have any questions or if you want to collaborate on internet-wide research, then you can shoot me a DM. If you have any questions, you can ask them. All right, thank you all.